So hello everyone, we're coming to the end of the day. Thanks for sticking with us. My name is James Luteric. I'm a solution architect, and for my job, I basically get to travel around North America helping brands build new commerce experiences. Sometimes that's weird, unique use cases that they're trying to go after. Other times they're transitioning from old, legacy systems on their own servers into the cloud. So that's basically my job, is getting to help them build those out and see how they're doing things and help them, architect their solution. So I do have to apologize if you read the description and the title. That was based on an original talk that I submitted that was supposed to be a lot longer. It did talk about, building out microservices, deploying them to AWS Lambda, using an API gateway with a CI/CD pipeline, with GitHub Actions. On the plus side, you get to go see the original slide deck and all the example code if you go over to the GitHub. On the plus side, I'm going to go ahead and focus on what use cases I actually see in the enterprise and basically what architectural patterns I see serverless being used for. So I work for a company called Commerce Tools. Call them out really quickly. They're an API-first, API-only commerce solution. It's a SaaS solution built on the cloud, designed to be working within the cloud. I really enjoy working here, and I have to thank them because they did send me to come speak at this conference from our US office over in Durham, North Carolina. So they did fund that. So although Commerce Tools is just an API, it's completely headless. We do have some demo sites showing off the functionality of that API. We call those Sunrise. One of them is a Vue.js single-page application. It uses the GraphQL endpoint that we offer as the back end. So here you have a full website with no back end, just a set of browser-side files powering everything. So we debate internally, does this count as serverless? There technically is no server. But a lot of people still believe that serverless equals functions as a service. I mean, after all, can you call yourself serverless if you haven't deployed at least one Lambda, Google function, or Azure function into your final deployment? I would say yes. I think fast is part of serverless. But if I were to define it, I'd define it a lot of the ways people before me today have defined it, where it's a system where you don't control the server. You don't get to install updates, you don't get to apply patches, you don't get to change the configuration, and most importantly for me is you're not responsible for the uptime. It's someone else's DevOps or operations person that's getting that call on Sunday night when the server goes down. So that's how I define serverless, is that aspect of it's not my uptime, it's someone else's problem. And if you define it that way, then not all fast is serverless. Kubeless and OpenFast are really awesome open source projects. They allow you to run functions as a service in your own Kubernetes cluster, but now you're managing a Kubernetes cluster. You have a server. So through that definition, fast does not necessarily mean serverless. So when you start talking about serverless tooling, there are so many options out there today. That ecosystem has really grown. And some of these are really cool. Like, I really appreciate Claudia.js and how it doesn't make you change your code to do a deployment. But when I start working with companies in the enterprise space, people starting it for the first time, they're really not interested in most of these. At the end of the day, I see most of them using the serverless framework. Maybe it's because it's the first thing you find when you Google it, or it could just be that it's the biggest, most supported one right now, and it offers, cross-cloud deployment, which is nice. The other one that I see being used most often is Terraform. I feel like in the enterprise, Terraform has taken over the infrastructure as code space. That includes, all cloud offerings, because most of these solutions aren't just serverless. They're usually building out a suite of items to make their solution. So if you're looking into the DevOps space, definitely need to get to know Terraform and what it offers. So going into some use cases and patterns that I see as I'm out there. The first one is basic event handling. An event is pushed to a queue, and then a Lambda processes the event. I should mention that all of my slides talk about AWS because I was an AWS early adopter. It's what I'm comfortable with, but most of these patterns will be cross-cloud. So if you're using Azure or Google, you're all set. So yeah, so that event gets pushed into the queue, and Lambda is going to process that event and do whatever action needs to be taken. Very common scenario that I see every time I do this is an order is placed, that order goes into the queue, and then that order has to go to the shipping provider, the business intelligence tooling, and OMS for customer service purposes, and so on. So it's really acting as glue between the systems to move data around real time. And I see this as the first step of people dipping their toe into serverless, and it makes sense. It's very low risk. It's all asynchronous. There's no customer waiting for a response. They don't have to worry about whether it's going to be slow or they're going to hit cold starts because it can all happen in the background. So this makes sense for people dipping their toe into serverless or not sure if they want to use it or not. The next one I see, surprisingly, is scheduled jobs because we all want to write greenfield applications and start from scratch and make everything perfect, but in reality, we all have a lot of legacy stuff that we have to deal with. And all those legacy systems don't necessarily play nice. Most of them don't have events. Some of them don't even have APIs. You might be lucky if you get a file kicked out once a day that you get to process. And when you start looking at processing files once a day with serverless, you're like, well, wait a minute, I've got 5 minutes to run all of my code. How do I handle this? So the paradigm I see is that one function takes on that file and splits it up into separate events into the queue. So if you're importing products, each line of that CSV file is going to go into its own event to get imported into the different areas. So it's all about breaking it up into smaller pieces. After companies get a little more comfortable with serverless, they start saying, all right, I'm gonna build my entire website experience on it. And they start off with this single-page application-centric design where the front end becomes everything to your application. It's coordinating all the systems. It's handling all the business logic. It basically makes your front-end engineers full-stack developers that end up doing it all. And I think this is a good approach. It works well. But personally, I like to use another set of services to be aggregators. So here's where you can create additional microservices that will turn around and talk to all the different services that you're using, all the SaaS providers, all the databases, any other systems in play. And you're going to aggregate the responses and you're going to format them so that they're exactly what your single page application needs. The front-end developer gets exactly what they want data-wise, and they get to post the data exactly as they need to. There's some vanity aspects here. If I now go into developer tools and say, what's your SPA doing? All I see is your own domain. So, you're hiding away all the underlying pinnings. But in addition to that, once you go beyond a website and start talking about other user touch points, whether it's voice controlled or native applications, or maybe an in-store kiosk, you have one central location for all your business logic. And if you need to swap out a payment provider, you do it in one spot instead of every single touch point, every single thing you're doing. So I do like this pattern of aggregator services. A surprising one for me is that I've seen clients using serverless to do throttling. We talked about pulling data out of legacy systems, but in the world of e-commerce, there are definitely spikes in traffic. Black Friday, you'll see 3-4 times the amount of traffic you normally would, or maybe you push out a good coupon that really spikes the amount of traffic. And your cloud systems or your serverless systems will scale to meet that need, but your back office systems probably can't. So one approach you can take is to queue up anything that has to get pushed into those back office systems and pull them out at a known rate that those back office systems can handle. You're introducing some eventual consistency into the application, so sometimes it's tricky because you have customer service waiting for that order to come down, but it does prevent other systems coming down that aren't yet cloud native and launched into this ecosystem. So I don't think you can really talk about serverless patterns unless you bring up the image resizing example. I mean, it is a classic. And the classic example is user uploads an image to a bucket. That bucket upload kicks off an event that kicks off a Lambda, and the Lambda can resize the image and put it in a new destination bucket, finally being served by CloudFront. Maybe that Lambda also saves a record in a database saying, hey, this image was received. I will say I've seen diagrams with this where there's only one bucket and it's all being used in one spot. I would avoid doing that. You never want to serve from the bucket your users are uploading to. You don't know what they're going to do. But in real life, it's never this simple, right? The requirements always get added on. So here's the simplest set of requirements I can think of. We don't need one different image size. We need 3, more likely 5 or 10, or they want it dynamically resized. We also want to read out that EXIF data from the photo and maybe strip it for the final version. And maybe we're going to use some machine learning to screen those images for inappropriate content so people don't get banned. Or maybe there's doing, someone earlier talked about recognizing objects in the images for tagging it. So the first approach to taking that is use the same diagram and say, hey, I've got this function already hosted. Let's just add more code to it. Now we're just going to make it reach out to AWS recognition to do the machine learning stuff. And instead of pushing out 1 file, it's going to push out 3. And I think this works until the business keeps just layering on and asking for more, because we're programmers and that's what people do. They ask for more. And eventually that Lambda gets overloaded and it can't handle it anymore. So one way to split this out is through orchestration, where you can have one controlling function that orchestrates all the other pieces. So now you're bringing your functions back to a single responsibility, and then you have one function that's coordinating all the interactions between them. So it's going to kick off 3 processes for resizing, it's going to kick off a new function for reading that EXIF data, and it's going to kick off a new analyze function to do all that machine learning analysis. And it can kick these off in parallel, wait for the responses, and when it's all done, save them into the database, and you're all set to go. And this is a great pattern to go at. It gives you good control over what's happening. It makes it easy to understand and reason about the flow. If you need to debug things, you have a central location to say, hey, where are things failing? But on the other hand, if one item fails, depending how your function's written, your entire process might fail, and it might be harder to retry that. Because if you're retrying from the start, you might have already committed certain things that now you have to write over or clean up. In addition, again, the business always asks for things. Eventually, they might ask for too much, and you can no longer orchestrate it all from one place. So another paradigm is to go down a reactive approach or event-based approach, where that initial event that happened, that initial upload, is going to kick off all of your different functions together. And now they're all happening on their own time based on when they're able to execute. And in this approach, they're all doing their own thing, and you're probably writing all of the responses into that main database to understand what's going on. This is a great event-driven approach, but you do have to layer on more complexity, because now there's not one system that knows when everything's done. So what I've seen is people will add even more into it, and they'll add something like a ready check. This isn't a real-life example, but the simplest one I can think of is maybe that destination bucket has an event attached to it with your new function that validates that all the services have been done. Once it validates, then it can set a flag saying, hey, this resource is ready, go ahead and serve it to our users, or do whatever you're planning to do with it. And I don't think you have to pick one or the other, that event-driven approach or the orchestration. As you build out bigger and bigger systems, you're definitely going to pick and choose which one makes sense for the situation that you're in. Another place that I see customers coming in and starting to use serverless is for rapid development. They're using it for proof of concepts, they're using it for demos, or they're using it to get around the slow parts of their organization. Sometimes getting an EC2 instance set up for you to do development can take weeks in some companies. Whereas with the serverless framework, you can get everything up and running in minutes. I was going to do a code example, but I had to cut it for time, where I showed branching that GitHub would immediately make a full development environment that matched production. But you play with that on your own GitHub environment. But I think that's really powerful, that you can have all these development environments out there. You're no longer stuck with one dev, one stage, one test, and production. You can have as many dev environments, as many stagings as you need, and they match production. And it doesn't break the bank, because you're only paying for it based on the calls you're using. So I think that's a very popular use case for these smaller projects. Not to say that serverless is a silver bullet. We've all talked about it all day, that AWS Lambda has limitations. Amazon, Google, or Microsoft controls our server, and they control what we do with it. So they're going to limit our disk space and our memory and our time, our execution time, and so on. And we might hit those limitations, and that's going to force us to either re-architect our solution, going back to breaking it up into pieces, or going back to a container service or a more traditional server. And I think that even though serverless has more hype to it, this is one of the reasons that it's having a slower adoption than containers, because you can't lift and shift the way you can with other cloud services. These limitations force us to come up with new architectural patterns and redesign and rebuild, which in the end I think will be a good thing, because it'll be hardened and ready and cloud native. But on the pro side, I think the biggest one is those less operations. I spent many years of my life on call having to deal with down servers, and hopefully I will never have to do that again if we all go serverless. But you also have that built-in scaling, resilient to DDoS attacks, and a lot of people don't talk about it, but it does mitigate some errors, because if you have a error in your code and it crashes, it's just one instant crashing, and the next one's going to call up a new Lambda function and a new container for you, so you're all set. Memory leaks don't last very long when they're constantly getting refreshed. And then on the con side, biggest one I think is risk of cloud lock-in. I talked about the serverless framework. Yes, it is cross-platform. Yes, you can deploy to all the different clouds. But I see AWS and Microsoft really innovating in the serverless side, and their innovations create lock-in. Because if you're going for that lowest common denominator, you can't participate in the new cool things that they're constantly launching. AWS has made Lambda functions the glue between all their services, and I guarantee you their services don't perfectly match against what Azure's offering. The other con is cold starts, continues to get better, but still definitely a thing. Denial of wallet attack. When someone mentioned this to me, I had no idea what they were talking about. I'm like, no, you don't have to worry about denial of service. It'll just auto-scale. They go, yeah, if it auto-scales infinitely, your bill can get infinitely large. They're just going to keep hitting your API and costing you money. Thankfully, all the cloud services have systems in place to send you alerts or to shut things down when they start to get too expensive or they use up too many resources. And the last one that I think surprises people is higher costs. A single CPU cycle in Lambda does cost more than a single CPU cycle on a reserved EC2 instance. And I think that makes sense because you're paying them to do all of the operations side of everything. In reality, it probably ends up being cheaper if your service isn't called constantly, if you're not, if it's an infrequent thing or you're not able to perfectly manage the size of the instance to the amount of traffic you have. But if you're a really big service, you're a really big website serving tons and tons of traffic, you do have to make that call of whether it's better to use traditional cloud instances and hire some DevOps people, or to go serverless and pay for those costs, because API gateway can get expensive, especially compared to hosting your own load balancer. So last call, I do want to point out that we are hiring. We have offices all over the world, but we also hire a lot of remote employees. So if you're looking, programmer, DevOps, et cetera, please talk to me. And I'm right at time, so I just want to say thank you. If you have any questions, you can reach me on Twitter, LinkedIn, email, and I'll hang around outside the room for a few minutes after the talk for anyone who has questions. So thank you very much.